On this incredibly scary looking question, we want to take advantage of the fact that in order to add, you need common denominator. So for instance, if I had 2/9 plus 3/9, that would give me 5/9, but it's the common denominator on the bottom that allowed us to add this. So in this situation we're in here, we've got common denominators here and here. So it won't occur to a lot of people at first, but if you subtract by c² over that whole thing, square root of x² minus c², we subtract that from both sides, we'll end up with x² minus c² over square root of x² minus c². And that equals 39. So now we have it there. And if we actually surprisingly square both sides right now, we'll end up with 39 squared. In the denominator, squaring that thing is going to make the radical go away. So what we're doing right now is we're taking advantage of the fact that if I have square root of a, and then I square it, it'll just be a. So when we're squaring both sides here, like we said, we'll get 39 squared on the right, but in the denominator, we're just going to get x² minus c². In the numerator, we're going to get this entire green thing all squared. So one way to show that is to write it twice. x² minus c², x² minus c². And that puts us in a situation where it now cancels. This cancels with this, leaving us with x² minus c² equals 39 squared. The question is asking us to solve for x. They don't really make that very obvious, but the answers are all in terms of c. So that kind of means we want to get the other variable, the x by itself. So if we add c² to both sides, we have that square root of both sides, and we have x is the square root of c² plus 39 squared. And when you take a square root, for instance, if you take a square root of 25, the answer would be plus and minus 5. So we can't forget the plus and minus. Oftentimes we don't see it at all, but the one moment you forget it is when you'll need it. So the square root of all this is actually plus and minus the radical. And the one that's being offered to us is the minus. So the answer here is D.